Hi guys, it's Mrs. Austin. Welcome to your summary lesson on parent function transformations. So hopefully you read the directions in the Google post today and you finished classwork number 1, the matching activity for 2 points, and the Desmos activity questions 1 through 7 for the other 2 points. So this video just summarizes everything in one little cheat sheet package, and there's your classwork and homework attached. So if you opened up the homework, you'll see this handout, and this is where you're going to take notes and finish up number 1 through 13 for homework. All right, so this little cheat sheet goes through what a family of functions is, what we talked about last blocks. It's just functions with certain similar characteristics. They kind of all look the same. The parent function is the simplest function in that family of functions. So your basic x squared, your basic absolute value of x, all 9 parent functions we talked about last block. Today what you focused on was the transformation functions or offspring of that parent when numbers are added around the function. Okay, so the location depends on what variable it is. So this is the generic layout for any function. You did x squared for homework, and today you're going to be doing, when you have a degree 3, the cubic function, and when you have a degree 1/2, the square root function. So you did those during the Desmos activity, so you see what happens for all functions the same. So here the location is a, which is the number out front, b, which is inside the function in front of x, outside the parenthesis. H is the effect that's attached to x with a plus or minus, and then the number hanging out after the function is your k value. So those letters have to do with where the number is located. Now you already know from quadratics that hk is your vertex point. So that's the new location of the center, vertex, inflection point, the center of the graph. Okay. Now, A and B, you investigated and saw that they changed the shape and size of whatever function it was. So I have these broken up into 2 charts, rigid transformations, which do not affect the size and shape of the graph, only the position. So you have 2 different types. Rigid is your HK, and when A and B are negative, so that's these 4. And then the other 2, A and B, when they're different than 1, it changes the shape. So we're going to focus first on the rigid transformations. Everybody got in the homework that I checked already the vertical translations. So when you have a K value at the end here, any number plus or minus, it's going to shift it up or down. So the whole graph is going to shift up or down. If it's a positive K, then it's going to shift up. And if it's a negative K, it's going to shift down. So pretty easy. Everybody got that one. Horizontal translations, when you have a number inside your parenthesis with x, inside the function, attached to x with a plus or minus, that's going to shift your function right or left. So if you have a minus h, remember it's a minus in the formula. If you have a negative, that means h is positive. Okay, so h is positive here. It's going to shift to the right, and you just add h to your x value. If it's a plus h, that means it's a minus negative h. Your h is negative, and the graph will shift left. So you should have seen that with the square root and cubic function today, just like you did with the quadratic. Now that means you subtract h from the x value, and it'll shift left. Now, those are the 2 rigid ones, and you know from quadratics where the vertex used to be, where h and k are where the new vertex are. So you go over h and up or down k, and you hit your new vertex. Okay? Now, the only other rigid transformations that you'll see are where A is -1 or negative in nature, and B is a -1 or negative in nature. So if you have a -2 for A, it still has the -1 portion and a 2 value. So if it's negative, what you saw in the Desmos activity today, it should reflect over the x-axis, which means all those positive y's will become negative y's. And the same thing, and you really saw it in the square root function today, when the b value inside in front of x is negative, it reflected over the y-axis. That square root function flipped completely over the y-axis. So all the positive x's went negative. So these effects leave that shape exactly unchanged, but changes the position, flips it upside down, or moves it left or right and up and down. So those are what we call rigid transformations. The tougher ones to see, which we're going to cover now, are the non-rigid transformations. Okay, so the two non-rigid transformations that'll affect the size and shape of the graph, so it changes the size and shape, are the a and b value. So a, whether it's a 2 or a -2, the a value still has a 2. It's greater than 1. And what you notice is f of x is the same as y. So you're really just multiplying all the y values by an a number. If that number happens to be greater than 1, like 2, then it's going to be vertically stretched because all the y values are going to be 2 times as tall, so twice as tall. If it's a 3, and you saw this with the quadratic for homework, it's 3 times as tall, so you'll have a vertical stretch. Now, if that a value is a fraction between 0 and 1, and you tested 1/2 and 1/4 for homework, then you saw that it shrunk down or vertically compressed. And you take 1/2 of the y values or 1/4 of the y values, so it compresses down. And the last one is the b value. You saw where b is greater than 1, it horizontally compresses in. Say it's a 2 by 2, so all the x values are 1/2 what they were. So if your b value is 2, all the x's got halved to crush in and make it a smaller graph. If your b value was a fraction like 1/2, then what happened was it horizontally stretched. So the b value compresses or stretches based on the number. Greater than 1, it'll compress it in, which means the values will always be 1/b or half as wide. And when your b is 1/2, you flip it 1 divided by 1/2, all your x's are 2 times as wide. So they go out and stretch. So those are the two non-rigid transformations happen with a and b that changes the size and shape of your parent graph. All the others just move the location of it or flip it upside down. Okay, now we're going to be doing these in combinations. So what I wanted to go through with you today is sample problem 1 and 2. The first we're going to do is 1A through D. And again, this is on that homework handout. So this will help you with the homework. So the first one here, you're going to identify the parent function and describe the transformations. Right away, you look for symbols or degrees to know what parent function it is. So this is degree 2, so this is the quadratic parent function, x squared. Now, what's happening to the plain old parabola x squared when you add a -1 inside? Well, if you go to your cheat sheet above, you'll see that that's an h of +1, because in the formula, it's after a minus sign. So this graph is going to shift right 1 because we have an h of +1. And that's all you do. So we would take that normal quadratic function, which is at 0, we'd shift the vertex over 1 and draw the exact same u, and there we have it. It shifted 1 right. Now letter B, a little different. We have a degree 3, so that's going to be the cubic function, x cubed. And we have 2 numbers around it. We have a -5 hanging on at the end. If you look in your chart, that's a k value. So we have a k of -5. And what does that do? Well, it's going to shift down 5. So the whole cubic function graph is going to shift down 5. But we have a negative inside the function in front of x. So what letter is that? That's a b. And if our b is -1, if you look in that last line of the chart, then you know it also is going to reflect over the y-axis. And those would be the 2 effects, shifting down 5 and reflecting over the y-axis. Letter C, you see your symbols for the absolute value function. So that's absolute value. And you have a number inside with it and a number on the outside, -1. So inside, remember, in the formula above, it's always after a minus sign. So we have an h value of -4. So which way is it going to shift? Well, it's going to shift left 4. So that bottom of your V, that vertex of your V, is going to shift to the left 4. Now, you also have out in front of the function, a negative. So that's an a value of -1. So in addition to shifting to the left 4, it's also going to reflect over the x-axis. And we could draw, when we graph these next block, we'll know where it would land. So I'd shift it over, and I'd flip it upside down and draw my V that way. Okay, now I want to point out we call it evil inside because it looks like it's +4, but remember it's after a negative sign, so you always do the opposite. If it's +4, then it's left 4. If it were minus, then it would be right. All right, and the last one, letter D, I have a degree 1/3, so I know that's my cube root function, or you could see it as the cube root like that. All right, so that's our cube root function. And again, it's x to the 1/3 or just the cube root of x. And I have two numbers around it. I have a +7 hanging out at the end after the function. So that's a k of +7. Look in your chart. You're going to be going up 7. And I have an a value out here in front. The 3 is in front of the function. So that's an a value of 3. It's greater than 1. So I'm going to have a vertical stretch times 3. It's going to be 3 times as tall. Okay, and that's what you're going to be doing in the homework, is just locating those numbers. How did those numbers around our parent function affect it? And you're going to use your cheat sheet and answer those questions. All right, and the last section, sample 2. For this one, they're asking us to give the parent function, given the parent function that's there, and the description of the transformation, write the equation of the transformed function f of x. So we need to know what each transformation does and what letter it is, and we'll put it in the right spot. Now, a is a quadratic, easy. I always start with an easy one, x². So I know my degree is going to be a 2. Here we expand horizontally by a factor of 2. If we're expanding out, that's a b value, and we need to know that if I take those x's and expand it horizontally by a factor of 2, my b will be 1/2. So remember, it's the reciprocal 1 over b. Look at your cheat sheet. So I know I have a b of 1/2, and I translate 7 units up. Well, going up, if you look in your chart, is a k value. So I have a k value of +7. So now I know in my function, it's a quadratic function, in front of my x, I need a 1/2 for the b value, and I add the k value at the end, and there's your function. All right, for the second one, cubic function, that would be x². Reflected over the y-axis, well, look in your chart, we know the b would have to be -1, and translated 9 units down, well, a k value would have to be -9 to translate down 9. And you plug it in your function. So f of x here is going to be in the function a -b in front of x. I'm going to cube all of that and subtract 9. And I'm done. Letter C, absolute value of x. We know what that looks like. Translated 3 up. So I have a k of +3. And translated 8 units to the right, my h value would be +8 because it's going to the right. So I plug it in my generic formula. I don't have an a or b, so I don't have to worry about that. I'm going to have an x and then minus my h, which is 8. So it's x minus 8 to shift it right, 8. Oops, I forgot my absolute value symbols. Hold on. I need my symbols for absolute value. Oops. And to shift it up 3, I'm just going to add 3 at the end. Done. All right, and our last one there, reciprocal. We know that's x to the -1 power, or 1 over x. And we're translating 1 unit up. Up is positive, so I have a k of +1. And I'm reflecting over the x-axis. go to your cheat sheet, and a has to be -1 to reflect it over the x-axis. So for that function, I'm going to have f of x equals, and I'm going to have a k and an a. So in front of my x to the -1, I'm going to have to put a negative sign or a -1 for my a value to flip it over the x-axis, and I'm going to have a +1 after it to shift it up 1. Now, if you're doing it as a fraction, you would have a -1 over x and then +1. So either of those would be acceptable. So what you're going to do for homework is number 1 through 13. Number 1 and 2 are just asking you to graph some parent functions together on the same graph. List the domain, range, and symmetry. What do you see that's the same? And then number 3 through 6 is just what we did earlier in sample problems 1. 7 through 10 is what we did in sample problem 2. And then there are 3 multiple choice questions. So you're going to upload this for next block. If you have questions like I put in today's Google post, you can see me during the student support block in the morning tomorrow. And I'll see you in class next block. Have a great weekend. Bye.